Welcome back, everyone, and today we're going to explore something that we probably need to be doing soon in the future, and it's deferred lighting. We've done a lot of videos of deferred rendering when we're doing emissions and post effects. We did a lot of that where we render everything into a custom frame buffer, and then we render it back out to the main buffer using a quad. Now, that's deferred rendering because you do a bunch of things and then you render your scene and then you manipulate the scene any way you want. Now, deferred lighting is the same process as deferred rendering. Now, the only difference is instead of rendering our entire scene into one frame buffer, we're going to render a bunch of data into a frame buffer. And here's a great example from Learn OpenGL is that in your frame buffer, you create a bunch of textures. And you store bits of information like position, normals, albedo. Albedo is just color, and you can specular, and whatever else you want. There's other examples online you can find. There's like different things you can store, shadows and fall off, and whatever else you want to do. However you want to handle your deferred lighting system. And today in the one I'm doing for this video, I'm storing position, normals, color, depth, and emissions. So I'm not doing specular, but you can do specular if you really want to. You just add another color texture to your frame buffer, and just fix your shaders to accommodate that new bit of information that you want to store. So let's kind of get to it a little bit. So, frame buffers, right? We've done it before. So I have a new function, a new class called deferred rendering, and what's the first thing it's going to do is create a custom frame buffer. And we've done this before in the past. All we've done is create the color buffer and the depth buffer. Sometimes we've done other things before, like color picking. Color picking also used deferred rendering, as that's why we would store like. For color picking, we store the ID number. In the previous video, we've done deferred rendering, and we stored the UV values in the color buffer. So this way, so when we click on this anywhere on the screen, we automatically get the UV value of texture of our it was our terrain editor. So this way, we click anywhere on the terrain, we know exactly what the UV value is. So this way, we can draw right on it. So we've done so much with frame buffers. Now. With today, we're going to deal with the lighting. So we're going to store all the information we need for lighting. And normally what we need for lighting is normals and positions. And the position is the position of that pixel in world space. And on top of that, we're also saving emissions because I like to be able to make things glow as well. And then depth buffer definitely because we need the depth buffer for other things in the future. Can't remember if I'm using anything for lighting. Probably not for lighting, but definitely other things in the future. And of course, we need a quad that we're gonna do our final render to the screen, and then everything else is kind of pretty much what you expect. You have a render function, and it just handles all the main things that we've done in the past. So, like I said, not too much difference, except for now we're storing 3 extra bits of information. Now the thing is, with all our shaders that's going to use post rendering has to be built for post lighting or deferred lighting. So I have like a new folder like in fungi mods called deferred, and in there I have shaders. And I used to have a function. I have a shader in here called low poly fong, which would highlight everything with lighting per object. When we're dealing with post rendering, we want to save the data, not actually render the lighting. So this one is much more simpler. You just see regular shader information, and we want to get world position. We want to pass that into our fragment shader, and then we, just like all our other frame buffer stuff, we just render out to that specific color texture. And as you can see, I'm saving my color, my world position, my normals, and I'm calculating the normals. That's why I call it the low poly color. So it just it automatically calculates the normals for low poly. Like if I have a model that has no normals at all, that's why I'm using the shader. So this way I can just quickly get normal information. And I can save emissions too, but I have that commented out for now. So that stores all the information into our little thing. So if I were to go and render, this right now is actually displaying our color texture. This is the color frame buffer. Like right here where it says albedo. Oops. Right now I'm actually displaying the albedo texture. And to prove it, if we go into our Phong lighting, which now exists in deferred shaders, and right here at the very top of our fragment shader, I'm getting our coordinates, UV coordinates, and that texture from the frame buffer. I'm just grabbing the color text, which, in case you remember, B color, P position, P normal, B emissions. If I go back in here, I have the same thing: color text, normal text, emissions text, depth text, position text, textures. So we can, if you want, just to prove it, we can go through every single color texture. That's our normals. That's what our normals look like. Emissions should be empty because I'm not storing anything in the emissions. So it should be like a blank screen. We can see our depth buffer. Hard to tell, but if I zoom in, you can see, because a depth buffer only stores data in the R channel, or basically I think all the channel. No, I think it's just the R channel. So it's a 0 to 1 value, and if it's 0, you are close to the camera. If you're 1, you're the furthest rendering point from the camera. So that's why the redder it gets, the further you are from the camera. So that's our depth buffer. And then we have our position buffer, our position texture. There you go. And that's what our position, that's what world position looks like when you store it as color data. So with that out of the way, we're gonna go. So when you're all said and done, you rendered your scene, you have your 4 textures all filled up with data. Now you need to start taking it apart. So the first thing we're going to do is we're going to use a depth buffer, and we're going to discard anything that's beyond the camera. So if there's anything in the scene for some reason that's being rendered that is not part of the scene, we can get rid of it. I think if we don't do that, we get some kind of weird artifacts. I can't remember. So that's what our scene looks like with deferred rendering, or lighting, I should say. Let's see what happens over here. I guess nothing really happens. But the idea, if there's absolutely nothing to render, it's better off not doing any of this code. Just automatically skip this fragment and move on to the next world. Because we can actually render this entire scene, and the first thing we can do is actually render the background and then render this on top. So there's a lot of things you can do when you're doing deferred rendering. So that's why I'm kind of like discarding it. It's like, just in case I drew like the background, like the sky box first, then I'm drawing the scene on top of it. Because anything that's beyond the camera, you don't want to light. So if I have like a sky box, I want to render that. I might want to render that first because I don't want any lighting done to it. And then I'll render this on top of the sky box, which I want to do some lighting. So once we're making sure we're discarding anything that's beyond the depth from our camera, and making sure it becomes like completely like 0, but like we don't change anything that's currently in the frame buffer that we're rendering to the scene. We're gonna grab our colors, we're gonna grab our normals, and we're gonna grab our emissions. If we have no normals, let's say like for some reason our normals, if you add them up, is 0 or less than 0, we don't want to apply any lighting to it. We're just going to say the color. If there is an emission color to it, and we don't want to add lighting to it as well. So if we add up emissions and it's greater than 0, that means there's an emission color applied to this specific pixel that we're rendering. So we're just going to render the color itself, like because emissions don't have lighting. Emissions usually is a source of light. So that's why I have this if statement, the block out, so we don't add lighting to emissions. And then we just have a regular Phong lighting done. And we get our world position from the texture itself, and that's it. It's just everything else is the same that we've done Phong lighting for the past year. So, and that's it. And this is Phong, and this is deferred lighting. It's like I said, we took all those little pieces and created this. Now, one thing I did add to the system, added a new UBO, which gives me light position. So this way I can kind of control light on a global scale. So I'm not just applying lighting like in previously when we were doing forward rendering, which we lit every object individually. I had to pass in the light position. So for this and moving forward, I'm going to start building more UBOs and have things more globally set up. So we have a UBO for lighting. And it probably should be in here. So we have our UBO for transform, and we have a UBO for lighting. So we have the lighting set up. And because of that, we can then just automatically set the color at the global level. So we don't have to worry about putting it in the shaders or anything like this. We set it up. So this little bit of code just moves the light around, and I update the value, the light position, in our UBO. I click refresh. And there you go. Our light source is moving. It's kind of just moving back and forth. Kind of hard to tell. But you can see that the cone is, the lighting's changing because I'm moving the light source. And like I said, I'm moving the light position. So that's another little thing I added in. We've done a lot of UBOs in the past, so it's, like I said, it's nothing different. And emissions, let's see how emissions work. So we've done a video about emissions and how to make the glow effect, which uses a blur. So you can't tell, there's nothing there because I'm not saving emissions. So if I go into Phong lighting, actually no, the low poly color, and I want to say this specific color, I want to store an emission. So that means that emission color has no light source. It becomes a light source. And then I apply a blur on that texture, that emissions texture, and then I render that on top of this. So this becomes, because if you remember correctly in the previous one of the previous videos when we're dealing with glowing emissions, I think it was like it was like a neon thing. It's a post effect. So when all said and done, it's just the post effect. So it's just another thing we can just add on to the very end. So like right here, like I said, this is a regular rendering. We have our scene rendered, and then we take our emissions, and we do a blur thing to it, and then we render that up on top of the scene. So the last thing we can deal with, let me take away emissions because I want to keep things lit and not things glowing. That's that. And the last thing we can do when we're dealing with all this post rendering and post lighting, so we're going to get rid of our regular deferred lighting. So if we want, we can, the last thing we can do is do deferred lighting, then we can which is deferred rendering, and then have everything prepared, packaged up, and ready to go. And then we can kind of continue further with forward rendering. Like if for some reason we're going to create a scene and then we want to do post effects, maybe we want to add more things on top of the scene, we might need forward rendering after that. So to set up forward rendering, after you've done doing your deferred rendering, It's pretty simple. You render your scene. And defer activate. Is it the same thing? So, all right. So the same thing. All right. So we activate our deferred rendering. We render our scene into our deferred frame buffer. And then when we render out to it, like over here, I have it equal to blank. So that means it switches to the screen buffer and renders into the screen buffer. But this one, I'm passing in a new frame buffer, another custom frame buffer. So instead of rendering to the screen buffer, I'm rendering into another frame buffer. So from one frame buffer to another. And at the very top, I have it right here. It's the default frame buffer we've been using for a long time. It's FBO. If I scroll it straight to the bottom, it's like a basic, simple one. It's just color and depth. That's all it is. It's just a custom frame buffer. Very basic frame buffer. So we're rendering our deferred lighting into that texture. And if you want, like I said, we can then start rendering things to it, and then we render our scene. So if I were to do that, now you see I'm rendering another item to the thing. But the problem is that when I'm rendering any object, I am what I'm rendering here is has depth. And then when I render the scene itself actually has no depth. It's actually a flat because it's just a quad. So if I want to make the scene usable for forward rendering, I need to save its depth. So in FBO, I created a new function, which we've done this before. We have blitz. And in case you haven't seen the video about blitzing, blitz is just a function for OpenGL that allows you to copy data from one frame buffer to another. So the regular blitz function that I did copied your color buffer and your depth buffer. The blitz depth only copies over the depth buffer. So our deferred rendering has depth. So I'm taking all that depth data and copying it over to our new custom frame buffer, the basic frame buffer, and having that depth data copied over. So this way we can continue rendering while keeping all our depth data. So this one actually just copies over the color buffer bit, and over here copies over the depth buffer bit. So this one, I don't think this function actually copies over depth. I think it just copies over the color, and this one copies over depth. Like I said, overall it's the exact same code. The only difference is what am I copying over. So I'm copying over depth. So if I were to copy over the depth data before I start doing my forward rendering, this will then work. Now it uses the depth data, and I can do depth testing. So I do deferred lighting. I render the entire scene, and then I can actually, let's say, copy blitz. And if I want to, like I can probably do it this way too. Can I? Probably not. No. Because what I'm doing here, okay, that's why. Because I need to change some code. But once I copy over the depth into our pre-render frame buffer, I'm now drawing into that pre-frame render buffer. So basically, we're creating a brand new scene that we're rendering. And when we're all done with our new scene, we then render it out one more time to the actual screen buffer. So this is an example, like I said, of doing deferred lighting and then switching gears into forward rendering. So this way you can kind of do post effects while using depth information to kind of so you can actually draw objects in there and not have them overlap everything that's in the scene. So having this blitz depth does wonders. Just one call before you start doing all your forward rendering is all you need. And yeah, and there you go. And like I said, that has no lighting because that is not part of our deferred lighting stuff. If I wanted that stuff to be part of our deferred lighting, I just make sure it's part of the scene when it's actually rendering all the lighting stuff. And there you go. Now it's part of our scene, and it's got deferred lighting applied to it. And that's it. And that is deferred lighting in a nutshell. I guess to recap, like I said, you create a frame buffer. You store all your bits of information in each texture. And then at the end, you do your regular deferred rendering. And you just sample all that data and then just use it as you would if you were rendering as forward rendering. Like I said, you have to get world position this way. Some little things, you don't necessarily need to save world position by using a depth buffer. There is some code out there I found. I had it and I kind of lost it. That you can take the depth data and the screen position, and that will give you a very close approximation of world space value. So it gives you really close to what world space is, so you don't have to save world space. You can calculate world space in the shader as long as you have the depth buffer. I think the only difference, you just need to apply extra information. You have to know what your near and far is, so this way you can then calculate the proper Z position in world space. I didn't do it. I think I did do it, and then later on, like I said, I lost it, and then I did it this way, because it makes it easier and it's perfectly exact if you're saving the world position. But like I said, if you can get a pretty good close approximate world space. You can calculate that yourself if you want to take away one buffer that you're dealing with. But like I said, this makes it so much easier if I just deal with it. Like I said, the only drawbacks is that now I'm rendering an extra texture, so that means I'm wasting more memory on the GPU. That's the only thing you have to consider. I think there's a limit of how many textures you can have. I think it's like 16. So, when you're designing your deferred rendering and your deferred lighting, just keep that in mind. There's only so much information you can store, and sometimes you should probably combine data. You can save up to 4 a vec4 per texture. So sometimes you can store like little bits of information. Like if the normal value has 3, you can probably save something else in a W position inside your normal map. So this way, like if you need it, it's there. So you sample your normal, you get XYZ, that's your normal, and W can be whatever value is, like strength or lighting strength or whatever. There's like things like that. So just keep in mind, you be a little bit creative in how you store the data, because there's no point in saving a small bit of information by using a large texture. Like try to cram as much as possible into how you design your deferred lighting and your deferred rendering. And that's it. Deferred lighting is pretty easy. Overall, it's not that complicated. It's just frame buffers. That's it for today. Next video, I'm going to do shadow maps, which continues on from deferred lighting, because once we have deferred lighting in, deferred shadows is a lot easier to do with deferred lighting set up. So that's why I'm doing deferred lighting, so we can do shadow maps next, which just extends this with an extra texture that we're dealing with. We're going to deal with a shadow texture, so we can create shadows in our scene. So that'll be the next video, and that one's kind of much more complicated. That one was a pain in the ass to do, but yeah. So please like and subscribe. That helps out the channel. Again, thank you so much for all my Patreons out there. I really need to find a way to say thank you to you all. Yeah. If you guys have any questions, any suggestions, I'm doing deferred lighting and shadow maps because a viewer really asked about shadow maps I think a month or so ago. So now I'm doing it. So if you guys have something that you really want some examples of, that you want me to kind of go through, learn it, and explain it in my own little goofy way, just ask away, and I'll do my best. All right. So I guess see you guys in the next video when we're dealing with shadows.